Okay, so here I'm showing part of the electromagnetic spectrum. So from here over to here where we're seeing all of our colors, that's visible light. And of course, if we go beyond red visible light, we start to get into the infrared part of the electromagnetic spectrum. And if we go beyond the violet part of visible light, then we start to get into the ultraviolet part of the electromagnetic spectrum. And within visible light, we see all of the colors of the rainbow. Now, earlier in this lesson, we talked about how if you look at hydrogen's emission spectrum, you don't see all of the colors of the rainbow. Instead, you just see 4 colors. So you see this sort of violet color, a darker blue, a lighter blue, and then red light. The question is, why do we not see all of the colors of the rainbow in hydrogen's emission spectrum? And the answer is, we only see colors corresponding to the transitions within hydrogen's energy levels. So hydrogen's energy levels are actually shown on the next slide, and here they are. Okay, so hydrogen's energy levels are right here on the right of the slide. If you look at this diagram, okay, if an electron within hydrogen goes from the 6th energy level down to the 2nd level, that's going to emit a violet photon. If you go from the 5th level down to the 2nd level, that's going to emit a darker blue photon, and so on. So if we look here, what I actually did is I calculated the energy change for all of the transitions between level 5 and level 1. So if we have a look at this one here, the transition from energy level 3 to energy level 2, we see that we get the energy change that we calculated earlier, and we get the wavelength that we calculated earlier. And so what I want you to notice is, okay, all of these wavelengths here, these are UV wavelengths. And so you can't actually see them. They're invisible to the human eye. And these wavelengths here, these are infrared wavelengths. So again, they're invisible to the human eye. So the only wavelengths which we are able to see are these ones here, which are visible light. And you'll notice that not all of the colors of visible light show up there. It's only some of the colors. Now, I didn't calculate anything for level 6, just because the diagram that I had for hydrogen only went up to level 5. So that's why you're only seeing 3 colors here instead of 4. To see the 4th color, I would have had to do some calculations involving transitions from the 6th energy level, but I didn't want to do that. So anyway, this is just supposed to be explaining why you only see some colors in the spectrum and not all of them. Okay, continuing on to example number 2. So example 2 says, how many different wavelengths of light could be produced by an atom in n equals 3 moving back to the ground state? Okay, so if we have an electron in the 3rd energy level, that electron can go back to the ground state in several different ways. So remember, the ground state is n equals 1. So it can go down to the ground state by going all the way from n equals 3 to n equals 1 with no stops. Or it could go from n equals 3 to n equals 2, and then it could drop from n equals 2 to n equals 1. Each one of those transitions is going to make a different wavelength of light. So because we have 3 transitions, we would end up with 3 different wavelengths of photons showing up.